Good evening, sir.
Good evening,
Yeah, good
sir.
evening, Avinav. So today we'll start with new chapter in chemistry. I think everyone's exams are over. Avinav, are your exams over? I think today we shall start with metals. Today we'll be starting with metals and non-metals. That is the chapter which is remaining from chemistry.
Yes, sir.
From chemistry, you have two chapters remaining. You have metals and non-metals, and you have carbon and its compounds. Okay. So, however, we had done a little bit of carbon and compounds. We'll leave that carbon and compounds there only. We'll continue with metals and non-metals. Okay. And is there any one of you who is finding difficulty in writing any equation or formula? Anyone who is finding difficulty in writing the formula?
No, sir.
No. Okay. So let's do metals and non-metals. Okay, I'm sharing the screen. First of all, we'll study what are metals. We'll study the defining property of the metals. Okay. So in what way do we define the metals, or how can we say that a substance is a metal or a non-metal? Yes, Abhinav. How can we say that a substance is a metal or a non-metal?
Um,
Like when I say iron is a metal. Okay. So what is the basis that I say iron is a metal? When I say mercury is a metal. So what's the basis for it that I say it is a metal?
Sir, did you call me, sir? I was setting my audio.
No, I didn't call right now.
Okay, sir.
Okay. Okay. So Siddharth,
we can determine them by physical properties like sonorous, lustrous,
but mercury isn't sonorous,
but it's lustrous.
but it's lustrous. So why, if it's not solid also, then why we call it as a metal? And we call it as an exception to a metal, that it is an exception to metal, that it is liquid at room temperature.
Sir, because it looks like it.
Hmm? Yes, anyone can think of how can we say that a substance is metal?
Sir, its chemical properties.
Okay, so which chemical properties are there that are not present with which chemical properties? Think of, on the basis of which we say that yes, this is metal and this is non-metal. Am I audible to you all?
Yes, sir.
Sir,
Yes. So why? No responses? Okay, see. So, we will come to the definition. How do we say that it is a metal or a non-metal? But I think all of you must have an idea about a metal. The idea about a metal is that we identify a metal depending on its physical properties. The very first thing we observe is the physical properties. Okay? If you are given any substance, so what you can easily identify is its physical properties. Okay, anything you take in your hand, you will be easily able to identify its physical properties. Like you will be able to identify whether it is solid, liquid, or a gas. You will be able to identify whether it is lustrous or not. you will be able to identify it whether it's brittle or not. If you hammer it, if you hammer on that piece, is it breaking into pieces or not? Does it break into pieces or does it change its shape? For example, if you hammer a coal, if you hammer a piece of coal, so it will shatter into pieces. If you hammer a glass, it will shatter into pieces. But if you hammer an iron piece or an iron coin, so it won't shatter into pieces. It will change its shape, right? So these are the physical properties which we can easily identify. Physical properties are the properties of a substance which can be easily identified by looking at the substance, by performing some small experiments like electrical conductivity can be tested. You can test its solubility. So these are some of the things which we can say. So metals, we identify the metals basing or based on the basis of their physical and chemical properties, right? But there is a definition on the basis of which we can say that yes, this one is a metal and whether a given substance is metal or not. Okay, so we'll come to that property at uh, once we study about the complete details in physical properties. So if we look about the physical properties of any substance, the physical properties which we look, one minute. So about the physical properties, whenever I say the physical properties of a substance, so by physical properties I mean its melting point, I mean its boiling point, I mean its state, that is whether it's solid, liquid or gas, I mean its electrical conductivity, its uh, thermal conductivity, right? Can you think of any other physical properties? Its luster,
Heat
Sonorous,
temperature,
Malleable.
sonority,
Malleable.
activity.
ductility,
malleability, that is brittleness we can test. We can check whether it's malleable or brittle. Malleability, ductility, any other property?
sir, good or bad conductors of electricity.
Okay, good or bad conductors. Okay. You have good. So that's all we have done in thermal conductivity and electrical conductivity.
Sir, electropositive in nature.
Yes. See, electropositivity, it is the defining property. Okay, on the basis of the electropositivity, we are able to define that whether a given substance is a metal or a not or not. If it is electropositive, then it is metal. If it is not electropositive, then it's a non-metal. Got it? So that is the reason we say mercury to be a metal because it's electropositive. So one by one, we'll look up at the properties of all of them, like the melting point, boiling point, state. So what will be the state of all the metals?
Sir, solid,
Solid state. Solid
Solids.
or
Okay. All the metals they are solid at room temperature. The room temperature we consider to be the room temperature is considered to be 27 degrees centigrade. So all the metals, they are solid at room temperature except mercury. What about non-metals?
Sir, they
Sir,
are
sodium and potassium. What are they, sir?
Which one?
Sodium and potassium.
Sodium and
Potassium.
potassium. They are also solids at room temperature.
Okay, sir. But we can cut them with knife.
Yeah, but that is about their hardness, whether they are hard or soft.
Okay,
But they
sir.
are solids.
Okay, sir.
They are solids. So we got here that the metals, they are solids at room temperature except mercury. What about the non-metals? Are they also solids at room temperature? Yes.
Which metal?
What about non-metals? Are non-metals also solids at room temperature?
No, sir.
Except for bromine.
Some of the non-metals are
Sir,
solids, some are liquids, and some are gases. How many total non-metals are there? Yes. How many non-metals are there?
sir 20.
20,
Sir,
Sir,
maybe.
22.
22. Okay, if you look up at the periodic table, you'll find 17 elements which are considered to be non-metals. In the periodic table, you'll find 17 elements which are non-metals. That some are metals and some are metalloids. So most of them, so sulfur, phosphorus, carbon, they are the non-metals which occur in solid state. You have non-metals in the gaseous state, which is chlorine, fluorine, oxygen, nitrogen. All these are the gases which all these are the non-metals which occur in the gaseous state. Can you tell a non-metal which occur in the liquid state?
Bromine.
Bromine, yes. Bromine is the only non-metal which occur in the liquid state. All other are or all others occur in either solid or gaseous state. So non-metals you can find in all the three states. Then metals in their pure state have shining surface. This property is called as luster. So if you look up at metals, the metals have a shiny luster. Like you can identify a metal by looking at its shine. You can identify the shine of a silver color, the shine of gold. So their shine will be identified on the basis of iron, copper. Copper has a cupric brown luster. Aluminium has a slightly silvery luster or beige luster. So all the elements, they have their own luster. Luster means they have a shiny surface. So you'll find that metals are generally hard. So all the metals, they are generally hard. The hardness varies from metal to metal. So which all the metals are hard. Which all metals are there which are not hard? They are soft.
Sir, all the alkali metals.
All the alkali metals like potassium, sodium, cesium, francium. Okay. These are the elements which are soft, or the alkali metals. That means elements belonging to group 1. They are all soft metals. Then some of the metals, they can be beaten into sheets. This property is called as malleability. Not all the metals have this property. A few of the metals, they have this property of being beaten into sheets. So for example, copper, aluminum, iron, metals, gold, silver, they can all be beaten into sheets. You can beat those metals into sheets, or you can also draw them into wires. Then the next property is ductility. Ductility means they can be drawn into wires. See here, for a gold, its surprise is given that if you take 1 gram of gold, you can make a wire 2 kilometers long. So such metals, they have a high malleability and ductility. Okay, so we use metals vessels. Which property do we use?
Sir, your voice was breaking. Can you once again repeat it?
See, we use some metals for making cooking vessels. Like we use copper also for making cooking vessels. We use aluminium, iron for making cooking vessels. So which property of the metals do we utilize there?
Ductility.
Conduct.
Ductility.
Ductility. Don't we use their thermal conductivity?
Yes, sir.
Yes, sir.
Yes. Yes. So metals are used to make cooking vessels because of their thermal conductivity. They can easily transfer the heat from the flame into the food. So they are good conductors. Then we use metals to make them electric wires. The reason is that they are ductile and they are good conductors of electricity. So these are the physical properties. Metals are generally hard at room temperatures. Okay. Now we'll see some of the exceptions. Like we have seen that metals have luster. So which metal is there which doesn't have luster? Any exception to the property that metals have luster? Is there any exception to this property?
No, sir.
Yes, lead. So lead is the metal which does not have luster. So for all the properties, okay, can you have any metal which is not a good conductor of heat and electricity? Yes. Do you have any metal which is not a good conductor of heat and electricity? See, there is no metal which is not a good conductor of heat and electricity. Almost all the metals, they are good conductors of heat and electricity. Right? A metal which is liquid at room temperature.
Mercury.
Which one?
Mercury.
Yeah, mercury is the metal which is liquid at room temperature. Then Okay, so I think we have discussed all of the exceptions from metals. Okay, from the non-metals, let's look up at the exceptions from non-metals.
Sir,
So
metals.
from the, yeah,
Sir,
a non-metal which is a good conductor of electricity,
graphite.
graphite, and we just did a non-metal which is lustrous, a non-metal
Iodine.
which is lustrous.
Diamond.
Which
Iodine.
one?
Iodine.
Yeah, I think it's bromine.
Iodine.
Iodine is lustrous.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
A non-metal which is liquid at room temperature,
Bromine.
bromine.
Mean.
So I think these were the exceptions for the
Sir,
no. Okay, a non-metal which is
sir,
hard. Yes,
what about gallium and cesium? Are those metals?
gallium and gallium, cesium is a soft metal which belongs to the alkali groups.
Sir, sir, we didn't talk about the metals having high temperature, high melting points and boiling points.
Okay, okay. So that we are already discussing just now. Melting point and boiling. So gallium belongs to metalloids. Okay, and it has a low melting point. Gallium has a low melting point of around, I think, 25 to 30 degrees centigrade. Not 30, it's not, it's just near about 30, I think 30-35 centigrade is the melting point for gallium. Okay, so all the metals, they have high melting and boiling point. If you consider the hardness, a non-metal which is hard, Ionija, can you tell a non-metal which is hard?
Uh, Sir, diamond.
It's diamond. So diamond is the non-metal which is hard.
Yes, sir.
Yes. Anything else? So lead and mercury, they are comparatively poor conductors of heat. Okay, so the non-metals also we discussed. Non-metals. The non-metals, they are poor conductor of electricity. A few of them, they are good conductors of only one of them, like graphite, is a good conductor of electricity. So the properties we have discussed just quickly. So this first property, all metals except mercury exist as solid at room temperature. Then the second one is gallium and cesium, they have very low melting points. We just discussed. Gallium has a very low melting point. Cesium is a very soft metal, also having a low melting point. Iodine is a non-metal, but it is lustrous. Carbon is non-metal that can exist in different forms. It can exist in different forms. So each form is called an allotrope, like diamond and graphite. So diamond is hard, whereas graphite is a good conductor. Alkali metals like lithium, sodium, potassium, they are so soft that you can cut them with knife. So all the alkali metals, they are soft. Okay, so this one, just have a look at this activity and go through the activity. Think of what should happen. Just think of the activity. Take a magnesium ribbon and some sulfur powder. Burn the magnesium ribbon, connect the SS form, and dissolve them in water. So test the resultant solution with red and blue litmus. Is the product formed on burning magnesium acidic or basic? Is the product acidic or basic? Okay, see. So if you burn a magnesium ribbon and sulfur powder, so we are burning two things. Let us have a look at the activity, how the different situations flow. So burning of magnesium burns in presence of oxygen to form magnesium oxide, whereas sulfur will burn in presence of oxygen to form sulfur dioxide. So sulfur will burn to produce sulfur dioxide, magnesium will burn to produce magnesium dioxide. Test the resultant solution with red and blue litmus paper. So first we have burned the magnesium ribbon. So this magnesium oxide which is formed, this magnesium oxide in water. So this magnesium oxide plus water, it dissolves and it forms magnesium hydroxide, which is a base. So magnesium hydroxide is a base and it will convert your red litmus to blue. The next one is sulfur plus oxygen. If you burn, you will get sulfur dioxide gas. So next one is burn sulfur powder. Place a test tube over the burning sulfur to collect fumes produced. Add some water to the above test and shake. Above test tube and shake. Test the solution with blue and red litmus paper. So that means you are making a solution of sulfur dioxide in water. A solution of sulfur dioxide in water will produce H2SO3, sulfurous acid. So here you will have the formation of sulfurous acid, which is acidic in nature. So from this activity, we confirm that the metal oxides, they are basic in nature, whereas the non-metal oxides, they are acidic in nature. Got it? The non-metal oxides, they are acidic, whereas the metal oxides, they are basic in nature. Sumukh? Sumukh?
Yes, sir.
Yes. So answer these questions which are following. Okay, give an example of a metal which is liquid at room temperature. An example of a metal which
The
is liquid at room
mercury.
temperature. Mercury
Sir, next one is
can be
sodium.
easily cut with a knife.
Sodium.
Which one?
Sodium and potassium.
Sodium.
Yes, sir.
Okay. Then is the best conductor of heat. Which metal is the best conductor of heat?
Silver.
Okay. Which is a poor conductor of heat? A metal which is a poor conductor of heat. Dharya?
Don't know, sir.
Okay. Dharya?
Yes, sir.
Okay. A metal which is a poor conductor of heat.
Sir. 1 minute, sir.
Don't know. Mercury and lead. Just we read also. Mercury and lead. Mercury
So
and lead.
sir, so mercury is a liquid at room temperature and a poor conductor of heat.
It's a poor conductor, not a good conductor. Both mercury and lead, they are poor conductors of.
Sir, I was telling that liquid at liquid at room temperature and poor conductor of heat are the same, mercury.
Yeah, yeah. The meaning of malleable and ductile, this will explain by Moksha. Moksha. Yes, Moksha. Moksha.
sir.
Okay. Explain the meaning of malleable and ductile.
Sir, malleable means we can, by hammering, we can make them into thin sheets.
Hmm. And
And
ductile.
tactile means we can make a thread-like structure by heating it.
Okay.
The ability of a metal to be beaten.
Okay. Malleable means if you beat it, you can make it into sheets, and ductile means you can draw them into wires. Okay. So today we have finished the physical properties of the metals. Okay. We would like to move on to the chemical properties of metals also. I think everyone is clear with the physical properties of metals and non-metals.
Yes.
Okay. So see the in the chemical properties, whenever we talk of chemical properties, what are the things that we look for? When we look for any substance chemical properties, we look for its reactivity with oxygen. We look for its reactivity with water, reactivity with acids. We look for its nature, whether it is acidic or basic in nature. Okay. Then we look for reaction of with other substances, if there is some specific. Okay. So these are the properties which we will be looking for. Generally, see if we start with this chemical properties of metals, so we tend to forget what were the properties that we were studying. Okay. So just first of all, we'll be listing out the properties which we have to study over here. Okay, so just as a first property, we have to study the reaction of metals with oxygen. So that is what happens when the metals are burnt in air. That is the reaction of metals with oxygen. Then what happens when metals react with water? So this is reactivity of metals with water. And see, alongside we'll also do with the non-metals also. Okay. So after this, we have what happens when metals react with acids. Yeah. So if we are looking for so we were doing we see we have to study the reactivity series of the metals. So for today, it's all your task to remember the reactivity series. Okay. All of you must be able to remember the reactivity series. Okay. So there are
Yes, sir.
different methods by which you can try out to remember. Yes.
Nothing, sir.
So there are different methods by which you can remember it, like potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. Okay. So you have some, you can use some mnemonics over there to remember them. They are arranged in the order of their reactivity. That means the metals which are listed at the top, they are the most reactive, and those which are listed at the bottom, they are the least reactive. See, here we haven't arranged all the metals in the reactivity series. All the metals haven't been arranged. Only a few of them have been arranged here in the reactivity series to have a general idea of the reactivity. Got it. So you'll be getting questions only relating with the metals which you are studying in the reactivity series. Away from that, you won't be doing. All right. So we end the class for today. In the next class, we'll start with the chemical properties of metals and non-metals.
Okay, sir. Thank you,
Okay.
sir. Bye, sir.
Bye all of you. See you again in next class.
Thank you, sir.